All right, welcome to 1.2. We're breaking it up into two parts. The part one is called Reflections of Functions, and in your text it's on pages 16 to 31. Our curriculum outcomes, we're talking about outcome 30.8, which is to demonstrate understanding of functions, relations, and inverses, and the related equations resulting through the x-axis and the y-axis and the line y equals x. So we'll hit some of those things today, not all of them, but we will touch on some of them. Specifically, here's what you need to be able to do by the time this lesson is over. You need to be able to identify a reflection in the x-axis by examining both the equation of a function and the graph of a function. You need to be able to identify a reflection in the y-axis by examining both the equation and the graph of the function. And finally, you need to be able to write a new equation of a function if a reflection in the x or the y-axis has occurred, and probably even both eventually. So those are what we're trying to get done today. And to do that, we're going to go straight to Geogebra. And here I have got a function for you already. And this function is f of x, it's in blue. I've also got all the points labeled. You can see that point A is 1, 2, point B is 3, -1, point C 4, 1, and point D is 7, 1. So what we're going to do is we're going to reflect this whole thing in the y-axis. So the y-axis, if you don't remember, is the vertical axis. So in making a reflection, all I'm doing, I'm going to make these points red. I'm taking this point A, and if it's reflected in the y-axis, right now it's 1 unit to the right. That makes it 1 unit to the left. There's my point E. Point B over here happens to be 1, 2, 3 units to the left. So it'll be, 3 units to the right. It'll be 3 units to the left. Point C, 1, 2, 3, 4 units to the left, to the right, new one, 4 units to the left. And point D is at 7 units to the right. It ends up 7 units to the left. So I can connect the dots with all these things as well and get my new function. Now, what is really important for us is we want to see how this function has changed. Well, visually, we can see that it's been reflected, because that's what we're doing, reflecting in the y-axis. But what we really want to know is the points. So I should be able to grab these points, but I cannot for some reason. Oh, there we go. Point E, we can see has coordinates of -1, 2. Point F, we can see has coordinates of 3, -1. Point G has coordinates of -4, 1, and point H has coordinates of -7, 1. So what is it that has changed in these points? Well, if we take a look at each one separately, A and E, A was 1, 2, E is now -1, 2. B and F, B was 3, 1, now 3, -1, and F is -3, -1. G is -4, 1, where it was +4, 1, and H is -7, 1, where it was 7, 1. So I guess if we were to come to a conclusion, we can say that we know that something is reflected in the y-axis if all the x values for all the points have switched signs. So again, reflection in the y-axis if all the x points have switched signs. Okay, that's all fine and dandy. Let's try the x-axis. So what happens when there is a reflection in the x-axis? So again, we're going to plot some points. We'll change the color to, I don't know, something flashy maybe, a purple. So if we're reflecting this thing in the x-axis now, point A was 2 points above, 2 units above, so now it is 2 units below. Point B was 1 unit below, so when it gets reflected up 1 unit. And point C and D were both 1 unit up, so it gets reflected 1 unit below. Those were supposed to be purple, but never did happen. Okay. So what we've done is we've reflected this thing in the x-axis, or the horizontal axis. And now we can try and see what the graph will make. Connecting the dots, we will see our new graph. Looks pretty similar to the old graph. But what's more important to us are these points. So point I here, or as it's turned into M, point I has coordinates of 1, -2. Point J has coordinates 3, 1. Point K has coordinates 4, -1, and point L has coordinates of 7, -1. So comparing corresponding points again, A went from coordinates of 1, 2 to 1, -2. B went from 3, -1 to 3, 1. C, hiding there, went from 4, 1 to 4, -1. And D went from 7, 1 to 7, -1. So we can come to a conclusion that when a graph is reflected in the x-axis, or the horizontal axis, all the y values have switched signs. That's clear to see. So, quick summary. Reflection in the y-axis, all the x values switch signs. And reflection in the x-axis, all the y values switch signs. All right, a couple examples. We've got a question. If f of x equals x squared plus 3x plus 1, what would the new equation of the function be if it is reflected in the y-axis? And then what is it going to be if it's reflected in the x-axis? So, we know that if it's reflected in the y-axis, that all the x values have switched signs. So instead of having x, we know that they're all now the opposite signs. So they're all negative x's. So in function notation, we would write that as f of -x. Now remember that means we substitute in -x in for all the places that we saw regular x before. That leaves us with x squared minus 3x plus 1. And the appropriate way to write this would be f of -x. So this f of -x just means that it's reflected in the y-axis because all the x's have changed. Okay, so that is part A. Part B, we're going to find out what happens when it's reflected in the x-axis. So we said if it's reflected in the x-axis, we don't have y values anymore. And remember that y is the same as f of x. So we actually have a negative f of x. We have the y values switching signs, so negative f of x. Well, if f of x is x squared plus 3x plus 1, the negative f of x would be the negative of that function. I guess to write this appropriately, I should write it as negative f of x. So that negative just gets transferred through. Negative x squared, oops, that's a negative 3x minus 1. That is our new function. So that's the way the functions change. We just either substitute in a negative x if we're talking about the y-axis, and we substitute in a negative f of x if we're talking about reflection in the x-axis. Okay, last example. It says, give the coordinates of any point that appears on the graph of f of x equals x cubed minus 5x plus 2. What would its coordinates be if the function was reflected in the x-axis? And what would it be if it was reflected in the y-axis? So, what we're doing here is we are finding any point. Now, if we want to find any point, doesn't matter what the function is, we can plug in any value that we want. I'm going to plug in a value of 1. So when I plug in a value of 1, I will get, plugging that value in for x, so I will get a y coordinate. So when I plug that in, I get 1 minus 5, which is negative 4, plus 2, which is negative 2. So our point is 1 comma negative 2. That appears on this function. This one right here. That's terrible scribbling. If the function, that disappeared, but we remember that it is 1 comma negative 2. Now, if that function, if that function is reflected in the x-axis, we know that the y value changes. So that means this point just has a y value that has changed to 1 comma 2. And if we're going to the y-axis, then we know that the x value changes. And so the x value is just now negative 1 comma 2. So just trying to connect some things that we did last year to some things that we just learned. All right, in summary, we know that a function is reflected in the y-axis and that all the x values for all of its points switch signs. We've learned the notation for that. We have that as f of negative x. And we know that when a function is reflected in the x-axis, all the y values for all of its points switch signs, and that is now written as negative f of x. So that is reflections of functions. The assignment is on pages 28 to 31. Because we've split it up, you can't do all the questions, but you could do 1, 3, 4, and part 7, B and D. That's all for this evening. See you tomorrow.